Assalamu alaikum, sir. My name is Iman Kashyap. I'm a student at Athol Public School and Andrew College. I study in FSC second year. My question is, how is an atom bomb made and how does it produce a large amount of heat that destroys everything in seconds?
Bismillahir Rahmanir Rahim. Thank you, Iman Kashif. You have asked me this question that how does an atomic bomb work and how is it made? Very scary question. Well, before discussing that how is it made and how does it work, we'll have to understand some basic concepts first. Uh, let us discuss the fuel first, which is used inside the atomic bomb or inside a nuclear reactor. The fuel which is used inside the atomic bomb or a nuclear reactor to produce electricity is uranium. Honestly, whenever I hear or read this word uranium, it arouses curiosity and sometimes causes fear. You must have heard this word also. You have read about it in your chemistry book. Uranium is a gray, a silvery gray metal. It's almost uh, like the color of, similar to the color of my gray hair. So it's a gray silvery metal, and it is the heaviest chemical element with 92 protons in it. Its atomic number is 92. And in your periodic table, in naturally occurring elements, this is one of the heaviest because there are 92 naturally occurring elements, and this is the last one, 92nd. So this is the heaviest chemical element. It has 92 protons in its nucleus. It is very, very dense. It is 19 times denser than water. I mean, if you have 1 liter of water and 1 liter of uranium, 1 liter of water weighs 1 kilogram. The mass of 1 liter of water is 1 kilogram, almost 1 kilogram. And the mass of 1 liter of uranium is 19 kilograms. So it is 19 times heavier than the same amount of water. So it is very, very dense. So this density actually is the reason of its potential as a very high source of energy. Now, let us uh, go into the background of this word uranium, this metal. How was it discovered? Who discovered it? And uh, how was it discovered that it is a radioactive element? Well, in 1789, in 18th century, in the end of 18th century, there was a German chemist. His name was Martin Heinrich Klaproth. Martin Heinrich Klaproth. He was analyzing a mineral which was called pitchblende. Pitchblende. Now that mineral is called uraninite. Uraninite. During the analysis of that mineral, he discovered this element, uranium, in that element, in that mineral. and he named it uranium after the name of Uranus, the planet, which had been discovered only a few years earlier. उन्हीं सालों में यूरेनस भी डिस्कवर हुआ था, and he discovered uranium and he named it after Uranus. In the 19th century, uranium was used in making colorful glass and ceramics because the compounds of uranium produce colorful yellow-green fluorescence. So the people did not have an idea that this substance, uranium, is radioactive. It emits dangerous rays. They did not have any idea, so they used it for making colorful glass and ceramics. It was in 1896, 107 years later, when a French physicist, Henry Becquerel, you might have heard his name, Henry Becquerel, he discovered that this element, uranium, it emits rays. It emits rays, invisible rays, which cannot be seen. But these rays can make a photographic plate foggy. फोटोग्राफिक प्लेट पे जब ये पड़ती है तो उसको धुंधला देती है, उसको फॉगी कर देती है. तो ही डिस्कवर्ड दैट यूरेनियम emits rays which can make a photographic plate foggy. And then his discovery opened the gate to research of radioactivity. Then you must have heard the name of Marie and Pierre Curie. Marie and Pierre Curie, they then started doing research on radioactivity, and they discovered that even other elements like radium and polonium are also radioactive. They also emit rays. Now, uranium has 3 isotopes. And you know, isotopes are the atoms of the same element which have the same number of protons but different number of neutrons. So uranium has 3 isotopes. The first isotope has atomic mass of 238 AMUs. The second is uranium-235, which has an atomic mass of 235 AMUs. And then is uranium-234, which has the mass number of 234 AMUs. And the atomic number of all the 3 isotopes is 92 because atomic number does not change. So these are the 3 isotopes. Of these 3 isotopes, I mean, when you take a lump of uranium, you will find that 99.3% of the atoms in that natural uranium, which is available or which is found in the world, in the earth crust, 99.3% is uranium-238, which is relatively stable. This uranium-238 does not have an unstable nucleus. It is relatively stable, though it can emit, and it emits radiation, but it has a stable nucleus. And uranium-235 is only 0.27% in the earth crust. Very, very small amount. 99.3% is uranium-238. Uranium-235 is only 0.27%, not even 0.3%. 0.27%. And then uranium-234 is 0.006%, negligible, very, very negligible. Of all these three isotopes, uranium-235 is fissile. Some people pronounce it fissile, some pronounce it fissile. So fissile means the material which has the ability to undergo nuclear fission. What is nuclear fission? When the nucleus of an atom splits apart, when a neutron is struck against its nucleus, and its nucleus absorbs and captures a neutron, that nucleus splits apart into two different nuclei. When uranium-235 splits, it produces two new elements, which are barium and krypton. Now, uranium-238 and uranium-234 are not used for making atomic bomb or for producing electricity in nuclear reactors. Only uranium-235 is used. And when uranium-235 absorbs one neutron, when one atom of uranium-235 absorbs one neutron, it becomes uranium-236. When it becomes uranium-236, it splits. It splits into two new elements, barium and krypton. And enormous amount of energy is released during the process. And this process is called nuclear fission. Nuclear fission, breakdown of the nucleus. Now, next is how much energy is produced when an atom of uranium-235 splits apart. Although when one atom splits apart, only tiny amount of energy is produced. But because there are trillions of atoms, and when they multiply, the amount of energy becomes staggering, enormous, astronomically high. Okay. Now, for comparison, let me tell you that one pellet of uranium-235 is about the size of a peanut, your fingertip, only 1 inch tall. It produces energy when it undergoes fission, nuclear fission. It produces energy equivalent to 17,000 cubic feet of natural gas, or more than 700 liters of petrol, or 1 ton of coal. Just a small pellet of uranium-235, only 1 inch tall. Look at the amount of energy it produces. Now, how does it happen? I'll go to the board. Uranium-235, which is a fissile isotope of uranium, when it absorbs one neutron, or one neutron is struck against an atom, or a nucleus of one atom of uranium-235 captures or absorbs a neutron, it becomes uranium-236. Because one neutron is added, so 235 becomes 236. And uranium-236 splits apart, producing two new elements. It's barium and krypton. Now look, the protons in the nucleus of barium are 56 and protons in the krypton are 36. Add them, it becomes 92. So uranium is 92. So number of protons remains same. But look at the number of neutrons now. Here, how many neutrons were there in U-236? 236 minus 92 is how much? 144? 144. 144. So 140, here we have 144 neutrons. Now look here. 141 plus 92. No, this is not 144, it's 134. Excuse me, 6 minus 2 is 4. 13 minus 9, 144. 144. So 144, and here add it. 2 plus 1, 3, 9 and 4, 13, and 1, 2, 34. Look the difference. Actually, what has happened is, in 235, how many neutrons you have? 143. 143. So from 143 neutrons, you have gone to how much? 143. So number of neutrons is 143 in these atoms. But remember, when uranium-235 splits, this one neutron is absorbed and it becomes uranium-236. When it splits into barium and krypton, it loses 3 electrons. It loses 3. You don't get 141 here and 92 here. No. You get 3 neutrons less. Then those 3 neutrons are absorbed by 3 different elements. Sorry, by 3 different atoms of uranium-235. And when those 3 atoms of uranium-235 split, 9 neutrons are released. When those 9 neutrons are absorbed by 9 atoms of uranium-235, 27 neutrons are released. When those 27 neutrons are absorbed by 27 atoms of uranium-235, 81 neutrons are released. So this is called chain reaction. And this chain reaction starts inside that fissile material uranium-235, and it takes millionth of a second to complete this reaction. So again, when one neutron is absorbed by uranium-235, it becomes uranium-236. When it splits into barium and krypton, 3 neutrons are released, and those 3 neutrons are absorbed by 3 atoms of uranium-235, and 9 neutrons are released. Those 9 neutrons are absorbed by 9 atoms of uranium-235. 27 neutrons are released. Those 27 neutrons are absorbed by 27 atoms of uranium-235, and 81 neutrons are released, and so on and so forth. And this is called chain reaction. This is called chain reaction. So you must understand What is nuclear fission? Nuclear fission is breakdown of the nucleus of uranium-235 into barium and krypton, and chain reaction is the further release of the neutrons in, and they keep on multiplying and keep on striking the atoms of uranium 235, and this chain reaction, it is completed in millions of a second, and enormous amount of energy is produced. Enormous amount of energy, and that I have told you how much energy is produced here. But to produce this amount of energy and to start the chain reaction, a critical mass of uranium 235 is required. And what is this critical mass? Critical mass is the minimum amount of material that is required to start the chain reaction. And the minimum amount of uranium 235 which is required to start chain reaction is 62 kilograms. If you have 62 kilograms of uranium 235, you can start the nuclear fission reaction, chain reaction. So this is the minimum amount of critical mass, is the minimum amount of material which is required to start the chain reaction. Then is, yes, I forgot to tell you, I should have told it before telling the detail about critical mass and chain reaction. There were two German scientists, Otto Hahn and Fritz Strassmann. In 1938, they were the first two physicists who demonstrated that uranium-235 atom can be split after absorbing a neutron into barium and krypton. They were the first two persons in 1938. And you must be knowing that in 1932, James Chadwick had already discovered neutron. So in 1932, neutron was discovered, and in 1938, they did this experiment, Otto Hahn and Fritz Strassmann, and they demonstrated it, that when an atom of uranium-235 absorbs a neutron, it splits into two elements, barium and krypton, and produces enormous amount of energy. Now, there is a term called uranium enrichment. This is a very commonly used term these days, particularly in the context of Iran and US conflict, which is going on these days. Iran is doing uranium enrichment, and America and Israel do not want him to do this. So that is the basic cause of conflict between these countries. So in Urdu, you must have heard the word afzudgi, uranium afzudgi. This is uranium enrichment. What is uranium enrichment? Well, it is a very lengthy topic. I'll explain it in my next video. But for the time being, you just understand that a uranium metal, natural uranium, has three isotopes in it: 238, 235, 234. Uranium enrichment is to increase the proportion of uranium-235 in the natural uranium. Uranium-235 के एटम्स को आपने कंसंट्रेट करना है, उनकी मिकदार ज्यादा करनी है. Why? Because naturally in the earth crust it is only 0.27%, which cannot uh, initiate chain reaction. The amount is so small that chain reaction cannot be initiated. Therefore, its enrichment is very essential. Either you use it in nuclear energy or nuclear weapon, enrichment is very, very uh, essential, basic thing which is to be done to use it for either peaceful purposes or for war purposes. Anyways, so enrichment is the process by which you increase the concentration of uranium-235 in the natural uranium. That I will explain in when I will in my next video explain uranium enrichment. Then you should be knowing that where this element uranium metal is found in the earth, in which countries. Significant amounts of uranium are found in Canada, America, Namibia, and Kazakhstan. And there are other countries also, but significant amounts of uranium is found in these 4 countries. Now, you must have gotten some idea of uranium by now. Now, it is not only the uranium which is used in the atomic bomb. There's another element also, which is not a naturally occurring element. That is called plutonium. Plutonium-239. Its atomic mass is 239, and its atomic number is 94. What was the atomic number of uranium? 92. And its atomic number is 94, meaning thereby it has 94 protons in its nucleus, and 239 is its atomic mass. Now subtract 94 from 239, you will get the number of neutrons. How do we get it? Well, it is born in the heart of the nuclear reactor. न्यूक्लियर रिएक्टर के अंदर ये प्रोड्यूस किया जाता है आर्टिफिशियली, मसनूई तरीके से. हाउ डू वी प्रोड्यूस इट? वी strike the atom of uranium-238 with a neutron. When uranium-238 atom absorbs a neutron, it undergoes transformation, different nuclear reactions, and eventually it becomes plutonium-239 with 94 atomic number. Now this plutonium is very, very chemically toxic and extremely radioactive. It is much, much more powerful than uranium. By the way, in 1945, the Second World War, the bomb that was dropped on Hiroshima used uranium-235. And its name was, what was the name of the bomb? Little Boy. Little Boy. And a few days after, another bomb which was dropped on Nagasaki, that used plutonium. That did not use uranium. That used plutonium instead of uranium. Now let us study something about plutonium. Its fission probability is very, very high as compared to uranium-235. Meaning thereby, plutonium-239 is more likely to catch a neutron than uranium-235. Clear? So the it starts its chain reaction with much less effort that is required to start a chain reaction in uranium-235. Now, critical mass. How much critical mass was required in case of uranium-235? 62 kg. And in case of plutonium-239, critical mass required is only 10 kg. And this 10 kg is much more powerful than uranium-235, 62 kg. So plutonium atomic bomb is smaller and lighter. So you can fix many plutonium atomic bombs in a missile, or you can load them onto a rocket. So many of them can be loaded. But because uranium is heavy, so you cannot load as many atomic bombs of uranium-235 as the plutonium-239. So it is less effort is required when you come to use to plutonium-239 atomic bomb. Yes. The principle which is used in plutonium atomic bomb is different. In uranium-235 atomic bomb, the principle was explosion. It exploded. फट गया ऐसे बाहर को. Like when you inflate a balloon and you keep on inflating it, गुब्बारा फुलाते जाएं तो फट जाएगा ना. तो यूरेनियम इस तरह फट गया. Okay, chain reaction जब start. But in case of plutonium, it was not explosion. It was implosion. Implosion, you can understand from this analogy. जब आप गुब्बारे को इन्फ्लेट करके आगे से टाई कर देते हैं, फिर आप उसको स्क्वीज करते हैं हर तरफ से, इस तरह दबाते हैं अंदर की तरफ, उसको छोटा करते हैं तो वो फट जाता है ना. दैट इज कॉल्ड इम्प्लोजन. जब आप इन्फ्लेट करके भर के उसको बर्स्ट कराते हैं तो वो एक्सप्लोजन है. जब आप उसको स्क्वीज करके बर्स्ट कराते हैं तो वो इम्प्लोजन है. और इन दैट केस the amount of energy released is much more than in the case of explosion. अब ये implosion कैसे होता है? This material, plutonium-239, 10 kg of 239 is surrounded by the conventional explosives. जो हमारे conventional TNT वगैरह ये explosive होते हैं, धमाका खेज मवाद जो होता है, उसके इर्द गिर्द वो रखा हुआ था उस बम में. दैट वाज इग्नाइटेड फर्स्ट. वो एक्सप्लोड हुआ तो दैट स्क्वीज्ड द प्लूटोनियम इनटू ए टाइनी मास. 10 केजी को उसने स्क्वीज करके बहुत छोटा बना दिया. इट वाज मेड सुपर डेंस. इतना डेंस, अब यू कैन इमेजिन द अमाउंट ऑफ एनर्जी which was trapped inside that very small piece of plutonium-235. Its weight was 10 kg, but its size was just this much. It was squeezed. When it was squeezed to a certain limit, it imploded. And a lot of astronomically high amount of energy was released. So this was the edge which plutonium-239 had over uranium-235. And the boom also was much larger, much greater than in case of uranium-235, which was dropped on Hiroshima. Boom, you understand, sudden and loud sound. It was much greater. And What is the next which I want to tell you? Uh, yes, that is uh, the last point, and you should be very clear about the difference between uranium and plutonium. That in case of plutonium 239, it has plutonium 239 has a much higher yield to weight ratio. Yield to weight ratio. I mean, the weight is small, 10 kg, and yield, the amount of energy released is much, much higher. So, Iman Kashif, I would like to conclude here because the video already has become quite big for you to consume. तो मेरा ख्याल है कि and the how an atomic bomb was made and how does it work, it requires a lot of details, and before that detail you need to understand the process of enrichment of uranium. So in my next lecture I will explain the enrichment, and if time allows, I will explain the making and functioning of atomic bomb and the nuclear reactor, peaceful use of nuclear energy also. Thank you very much, and Allah Hafiz.